So in previous session we actually discussed about how our integer numbers deep down stored in memory, right? So how a positive number is stored, how a negative number is stored. So I just quickly want to add a couple of points to it. So if I have an integer here and I want to store the smallest possible value in the integer, then what you can do is write integer dot min value here. So this will give you the minimum value an integer can store. And what is that value? We did discuss and I really hope you remember. So that is minus 2 to the power of 31. In case you want what is the largest possible value that an integer can store, so I should say this is min and this is the upper limit max. Then the largest possible value an integer can store actually is integer dot max value. And what was that value? So largest possible value that an integer can store, so this is minus of 2 to the power 31 and this is 2 to the power of 31 minus 1, right? So if we just try printing them, right? So let me just do this. So print min, if you want to print more than one values with spaces, you can write it this way. So min and max if you want to print, and if we run it, so this is the range, basically the smallest possible value and largest possible value an integer can store. You don't really have to memorize it. In fact, you just have to understand the logic and you should be able to figure out that what is that value for integer, for short, for long. So you can do it on your own. Right, so this was the smallest value, so the smallest value that an integer can store and a largest value that an integer can store. Now let's talk about chars. So how are chars stored in memory? So for that I'll comment it and let's say write something like this. So if I have a char here and I'm rotating it something like this, that actually means this will create a storage for me. Chars in Java are 2 bytes long. That means it reserves 16 bits and it is going to store A here. Now A in here as a character is not going to be stored ultimately, right? We have discussed it a lot of times now. Whatever you are creating, whatever you are storing ultimately has to be in binary. You cannot store A, B, C, D or any other character of that sort. So that actually means you will have to convert A to its binary representation. Now what will be binary representation of A? So for that matter, all characters that you have an ASCII value associated with it. So ASCII value for A is 97. That means when you are trying to store A in here, 97 in its binary form is ultimately going to be stored. So system will figure out that okay, you are talking about A, ASCII value of A is 97. It will convert 97 to binary and then store that binary value in system. Right? So this is how it is going to be. Similarly, if you have B, B will be 98 and so on. If you want to store capital A, it is going to be 65. In fact, 0 as a digit is also there. Character is also there. So this 0 is a character and its ASCII value is 48. So 0 is a character as well and it was an integer as well, we have seen this. But 0 as a character means 48 ASCII value. So you can put or store characters like this. So that means when you are storing A, actually 97 in binary form is stored. So you can definitely explore the ASCII table. I don't think there is any need to memorize it. You don't really have to memorize it, but the more you will use it, eventually you will recall things, right? So this is how it is. So I really hope that now you have some clarity on what is happening here. Now let's play around with some interesting things. Let's say I want to store or I want to print A plus 3. And now I'm just trying to print his. What do you think will be the value of A plus 3? So let's just run it and see. So A plus 3 is giving you 100. Now how is 100 being calculated? So in a very simple manner, when you are writing something like this, system knows that when you are trying to add a character, it has to deal with its ASCII value. So whenever you are dealing with characters, deep down system is dealing with the ASCII value. So the ASCII value for A is 97. 97 plus 3 is going to be 100, and which is what you are storing, which is what you are seeing on screen as well. Right? So you can definitely do this. This is absolutely okay. In fact, you can store it in an integer maybe I, and do something like this, right? And then print I, obviously. So printing I is going to give you 100, right? So I really hope that whatever we have done here makes sense to you. How characters are stored are somewhat clear to you. You have clarity around how you're dealing it, and remember one base rule: whenever you're dealing with characters, deep down it is dealing with the ASCII value, right? So system knows that it has to treat characters with associated with their ASCII values only. So whatever calculations, whatever operations you are performing on characters, it is actually performed on their ASCII. I hope this point is clear, because this is something which will be really important as we proceed along. Thank you.